So today we're diving into something that feels like a real architectural battleground in generative AI.
It really is. We're looking at a paper from ByteDance on a model they call NextFlow.
And it feels like they're taking a sledgehammer to the established rules.
That's a good way to put it. For years, the consensus has been, you have LLMs for reasoning and you have diffusion models for great images. Two separate things.
Right.
NextFlow says, why not one? It's a purely autoregressive system, a 7 billion parameter decoder-only transformer that tries to do it all in one go.
Okay, let's unpack this. One single model for interleaved text and images. But wait a minute. Autoregressive models for images. Haven't they always been incredibly slow, like prohibitively slow?
That is the core problem they had to crack. And you're right. The standard raster scan method, it's just painstaking. It builds the image sequentially.
So you're talking, what, 10 minutes or more for a single high-res image?
Easily, yeah. Over 10 minutes for a 1024 by 924 picture. It's just not practical for any real-world use.
So that's where the breakthrough had to happen. And it did. They call it next scale prediction.
Mm-hmm. It's a completely different paradigm.
And the numbers are just, they're staggering. They took that 10-minute task and knocked it down to 5 seconds.
5 seconds. And with 6 times fewer computations, fewer FLOPs than the top-tier diffusion models.
That's the efficiency that suddenly makes this whole unified idea, well, viable.
But that speed means nothing if the image quality falls apart, which is a classic failure mode when you try to scale these AR models up.
Right, you get weird artifacts, structural problems.
Exactly. So their solution, and this is the clever part, was scale-aware loss reweighting during training.
Okay, what does that mean in simple terms?
It means they essentially told the model, get the big picture right first. They heavily prioritize the coarse early tokens, the ones that define the overall layout.
Like a blueprint.
Precisely.
Mhm.
Build the blueprint first, make sure the structure is solid, and then worry about coloring in the fine details.
And that stable foundation is what unlocks everything else, right? More advanced stuff like editing and reasoning.
It's the key, because now you have a fast, stable, unified system. So when it comes to complex image editing, it excels.
I saw the numbers on the Edit Canvas benchmark.
An overall score of 8.04, state-of-the-art. But the really striking result for me was identity preservation.
The Omni context test.
Yeah, it scored a 9.22 on keeping a subject consistent through edits. I mean, that's better than G340 on that specific task. That's a huge deal.
And because it's all one sequential process, it can do what they call thinking with images.
Which sounds like marketing, but it's actually a perfect description.
It's chain of thought reasoning, but it happens before the image is even generated.
Right. The model can literally think to itself, okay, the request is for China's national treasure. That's a giant panda, not a red panda. It self-corrects.
And that actually improved his performance.
Substantially. Adding that chain of thought step boosted its logical consistency, the WISE score, from 0.6 all the way to 0.70. It proves the architecture helps it think better.
So when you put it all together, what are we looking at here? NextFlow seems like a radical proof of concept.
It is. It shows that a single decoder-only transformer can perceive, reason, and create across modalities. It challenges that whole idea that you need separate hybrid systems.
The future might just be unified, full stop.
And if you zoom out to the bigger picture, this unified AR structure has a unique advantage. You can apply standard reinforcement learning techniques directly to its reasoning paths.
Something a hybrid model just can't do as cleanly.
Not at all. They call it native multimodal chain of thought and unified RL. It's a pathway to self-improvement that's built right into the architecture.
And they're already talking about what's next, swapping out the dense architecture for a mixture of experts or MOE framework.
Which would scale it up massively.
So here's something to chew on. If a model like this keeps scaling with MOE, how does that change our very definition of visual and textual coherence when it all comes from one single dynamic mind?